Determination of alkalinity of water sample.
Hello guys, today we are going to learn about the alkalinity. So alkalinity is one of the what are called the parameter. Okay, so basically this comes under the chemical parameter of the water. So this is basically the measurement of the capacity. Okay, that is to neutralize acids. Okay, and it's also called the buffering capacity of the water body against the acid deposition. Okay, so generally it can be used to also foresee the photosynthetic productivity or the activity, and this is related to the or you can say compared to the O2 or to the hydrogen ions present in the water. And this can also be defined as the ability to neutralize acid. So pH and alkalinity are not the same thing, as we all know. Okay, so what is the difference between the alkali and the base? So base neutralize acid, we know that, and pH greater than to 7, it's not need to dissolve in water, but alkali needs to dissolve in water. So all alkali are bases, but not all bases are alkali. And water is alkaline due to the presence of one or more following salts. You can see we have the sodium hydroxide, potassium hydroxide, sodium carbonate, potassium carbonate, okay, and sodium bicarbonate, etc. Okay, so the common ions that contributes to alkalinity in natural water are hydroxide, carbonate, and bicarbonate. Okay, and alkalinity is expressed in terms of moles per liter, so which is the summation of bicarbonate plus twice the sum of the carbonate ions plus hydroxide ions, and this is an minus of the H plus ions. Alkalinity measurements are used in define and control of water and wastewater processes. Okay, and we all also know that the anaerobic digester, they have alkalinities that is in the range of 2000 to 4000 meters, 4000 milligram calcium carbonate per liter. Okay, and alkalinity can also be expressed in terms of moles per liter or as well as in terms of calcium carbonate scale. Okay, and low alkalinity has a toxic effect for methane bacteria, and which is less than 2000 ppm of calcium carbonate. And the procedure for doing the alkalinity is we have to take the titrant as 0.02 normal H2SO4. Okay, and or also we can use HCl or HNO3 as per the US EPA standard method. There are basically two types of alkalinity. The first one is the phenolphthalein alkalinity, and then we have the methyl orange alkalinity, and the indicator that we are going to use is methyl orange and phenolphthalein. So you can see here the plot is the pH versus the how much amount of the titrate we are going to consume. So the first range, you can see this is for the the HOH minus alkalinity, and this is the carbonate, and this is the again the carbonate and then bicarbonate. And this range is basically this range, and pH 1 to 4 is the range for the free mineral acids or CO2, or you can say the methyl orange alkalinity. So what we have to take as per the procedure, we have to take any amount of sample, then we have to check the pH, and then we have to drop certain amount of phenolphthalein indicator. So in that case, if the pH is greater than the if the pH is more than the 8 or 7, you can say 8, it's in the alkaline range, so the the sample will turn pink. Okay, if the pH is less than 8 or 7, so they would be it would be colorless. So at that point we will have no phenolphthalein alkalinity, so we'll continue with the methyl orange alkalinity. And then if it is more than 8.3, then what we will do, we'll titrate, because the titrate here is 0.02 normal sulfuric acid. Okay, then we have to titrate till we get the colorless endpoint, and then at that point we will know the volume of H2SO4 consumed. Okay, and also at that point we have to check the final pH. Okay, and then we will add again to that sample, we'll add methyl orange the indicator, and then we will titrate till we get the the final endpoint, that is the pink. Okay, and in another condition, if we don't get the pH, if the pH is not greater than 8.3, at that point we will have to add the methyl orange indicator. Okay, and then titrate till we get the final endpoint. So in that case, we'll just have the methyl orange alkalinity we will not have the the phenolphthalein alkalinity. So the formula for the calculation of the phenolphthalein alkalinity is the volume of the acid consumed into the normality of the acid into 50 into 1000 upon the sample volume. Similarly, for the methyl orange, it's the same in the same formula, means this the factor here, it is the volume of the the acid consumed into normality of the acid into 50 into 1000 upon sample volume. So the total alkalinity will be the sum of, if you mark here 1 and 2, so this will be sum of both the terminology. So now we will start the procedure. This was the explanation of the theory. Now the next step is to find out the pH of the water sample. So you can see here the pH is more than 8. Okay, so for this sample we have to add the phenolphthalein indicator. Similarly, for the second sample, here the pH is less than 8. So now what we will do, we will take 20 ml of the water sample from the first one, and then we will add the phenolphthalein indicator. We took the 20 ml of the water sample, okay, in this conical flask. I will add phenolphthalein indicator here. So you can see here the solution turned pink. Now I will try to sit. Okay, so I'm trying to purge the air bubbles. I'm setting again. Now I will add certain in this amount of acid, and at the end you will get the colorless. So slowly you can see the solution is turning. So we can see this much amount of acid is consumed. So this is my phenolphthalein point. So it's 1.77 ml. Now to the same sample I would add the methyl orange indicator. Now I have added methyl orange indicator. So you can see the solution is orangish. Now I will titrate till I get that point. So I will set again. I will slowly and slowly. So this is my final endpoint. So which is methyl orange point, which is 2.76 ml of the acid. Okay. Now we can repeat, okay, to get the accuracy. Okay. Now I would do the the analysis for the second sample. You can see, you saw that our tap water sample, okay, had no had pH less than 8. So I would add the phenolphthalein. You can see when I'm adding phenolphthalein, there is no color change. Okay, so we would directly add to this sample the methyl orange indicator. Okay, so this water has no phenolphthalein point, it has just the methyl orange point. So now we would add the titrant, which is the, okay, so this is just the 1.23. so this is for the alkaline water. Okay, and this for the tap water, we have methyl orange point as 1.23. For doing the calculation, we'll use this formula. Okay, so for the first sample, if you want to find out total alkalinity, or we can do one thing, we can find out the alkalinity separately. So phenolphthalein point will be 1.76. so normality here is 0.02, and already the acid is standardized. Okay, so 50 into 10,000, and this would be upon the volume of the sample. The volume of the sample is 20 ml, and this one would be 2.76 into 0.02 into 50 into 10,000. Okay, so this is 1000, sorry, upon 20. Okay, similarly for the tap water, it would be just 1.23 into 0.02 into 50 into 1000 upon 20. After calculating, we saw that the phenolphthalein endpoint or the phenolphthalein alkalinity for the, the alkaline water is 88, and methyl orange is 138. So the total alkalinity is the sum of the two, which is 226. And for the tap water, which is very low, this is just 61.5. So the tap water has a lower alkalinity as compared to the alkaline water.